Yeah, welcome everyone to Science Society, and of course, a special welcome to you here. Thank you so much for joining, making the account, and everything. We really appreciate you taking time out of your busy schedule to do this, and so that everyone will get to know you a little bit better. I'll give some background information
Mhm.
and we'll go from there. So, Dr. Gutami Somepalli, I hope I said that right. She is in computer science at the University of Maryland, College Park, and in Professor Tom Goldstein's lab. And her broader research, in her broader research, she focuses at the intersection of machine learning and computer vision with the aim of building practical machine learning systems that are interpretable and robust. And she has been working on developing novel deep learning architectures for different domains, such as images, graphs, to tables, to tools to explain and analyze the success and failure of models of common deep learning models. And she received different, awards and fellowships, and one of them was the Kulkarni Fellowship. And before she started her PhD, she worked in the industry for 8 years on various product and engineering roles, and she received her bachelor's from the IIT in Madras. And yeah, and she published various papers in really great journals. And as I said, she presented her work also at Google Research India and received a bunch of fellowships. So it's such an honor and pleasure having you here today. And Victoria usually asks a few interview questions before we dive deep into your research. Thank you.
Yeah, thank you so much for the kind introduction.
Thank you, Katarina. And once again, Gautami, thank you so much for joining us. Thank you for friends who are here. And also thank you for friends of the future who will be listening to the replays and all the places that you might find them. So we'd love to hear a bit more about you before we hear about your research. And what I'm wondering is if you can think of a time in your life when you felt or noticed this spark of interest that drew you towards science. And this can be anywhere in your lifetime, childhood, or anywhere through your education. So thank you.
Um, okay, science in general, I mean, from the childhood, in my family, we are very math and science oriented sort of people. Like my grandfather had like masters in physics. I mean, like which was kind of very few people had that like back in those days. So yeah, I mean, I would say like I have always been interested in science. And Katrina mentioned, like I did my undergrad in mechanical engineering. And after that, like I worked in industry for a few years, where I was like not really doing any sort of very hands-on engineering stuff, but I was mostly into management and all. But then I had a startup, and we were like a small team, and that's where I got my hands dirty and got into like computer science and machine learning to like for the first time. And then that's when I felt like it's quite exciting, and I did not know so much about it. Like I was doing mostly applied stuff at the time, and then I got like very curious about like how these models work and so on. So yeah, after I mean, like we ran the startup for like a few years, and we kind of like wrapped it up. After that, I felt like I mean. My friends, most of them suggested like, okay, you should be doing MBA at this point. Your profile is perfect for it. But then I felt like, okay, I don't feel like I would be happy doing an MBA. I think like a PhD is something probably which will give me time to understand more about machine learning and deep learning, yeah, that's how I landed in like University of Maryland. Yeah, doing like deep learning stuff.
Thank you. It sounds like you are really comfortable listening to your own intuition to where you want it to go. And then maybe you can take us on a step-by-step with big steps journey of how you arrived at the current research that you're doing today.
Oh yeah, yeah. Okay. So, I mean, like, I would say in the beginning, I was not very sure about like what sort of problems I should be working on. Like, if you look at most of the people like who start with PhD, they kind of already come with like certain problems in mind. But for me, like, I came as like a blank slate, and I was sort of open to any problem which interests me. So yeah, I kind of worked with like a few profs, and the good thing about University of Maryland is like most of the courses were like project oriented. So it gave me an opportunity to work on a bunch of projects without I mean having to invest so much time, because like they were all mostly group projects. And yeah, that kind of got me like I mean I was able to do like a lot of stuff, like a few vision projects, language projects, and so on. But I mostly ended up like I guess like a couple of years back, when I was kind of working on certain models, I realized like reproducibility was sort of an issue. Like I train a model with one seed, and then I get like correct answer, like, correct prediction, and then next time I kind of train it again, and I kind of get wrong prediction. Like there's so much uncertainty involved in the deep learning models, right? Like I mean, there's so many hyperparameters. Like every time you change something, you end up like at a different local minima. So that kind of like got me thinking about like, okay, how can we understand this reproducibility issue? So that's where I worked on. That's what I did for like last year, and where I published a paper at CVPR where we were trying to understand the reproducibility and quantify the reproducibility in different deep learning architectures. Yeah, and I kind of after that I was kind of working slightly in that area, but then diffusion models kind of blew up this year, and sorry, last year, and I kind of like started reading about them slowly, and then I mean everybody mostly focused on trying to improve the diffusion models, or like trying to find like this little trick which make them work for like something else. But at the same time, there are like a lot of discussions about like are diffusion models just copying from the training data? Is that why the generations are really good? Like, so this question has been going around, but nobody has an answer for it. So that's when we thought like my advisor and I, we were kind of discussing about it, and then we decided, okay, fine, why don't we like try to answer this question? So yeah, that's how I ended up doing this project. And yeah, it's been a journey. It's a very interesting project. It's technically not a diffusion project. It's actually, I would say, like is a retrieval project, but yeah, but we found like very interesting results. Like, yeah, that's how I ended up with this. I hope that answered your question.
Oh, it did. It did in a very interesting way too. It will be interesting to hear about how you quantified your observations. I have a question though. Can you please repeat the last thing that you said? You said that it wasn't really this, it's more of that, and I missed both of those words.
Oh, okay. I mean, I was saying it was not exactly like a generative modeling project, like, but it's more of a retrieval project. That's what I said. I mean, because like we are kind of not training. I mean, we are training diffusion models technically, but we are not trying to improve a diffusion model. We are just using the diffusion model, and we are actually using like retrieval methods to understand the replication. So yeah, that's what I was trying to say.
Okay, thank you. I'm glad I asked you because maybe somewhere along your discussion you could define the difference between those two examples for our
Oh,
listeners. So, if not now, then whenever it works for you. And at this point, I will hand you the mic and say the stage is yours and you're welcome to go into your discussion. And Katarina has your PDF pinned. And then at the end of your discussion, we can help with you to have a Q&A. And if anybody types any questions to you in the chat, then we'll also share those with you so you don't have that on your mind, just enjoying your talk.
Sure.
Thank you.
Yeah, I just have a quick question. I mean, should I mention like every time I change the slide number, just mention which slide I'm talking about?
Sure. Yes, that would be great.
Okay.
Yeah.
Okay. Okay. All right. Yeah, just before I get started, like, feel free to interrupt me if somebody has like a burning question, or yeah, if there is any question in the chat as well, like, because I would rather have more sort of a discussion sort of a session rather than like me kind of lecturing people.
Okay, got it. I heard you.
Okay. All right. Cool.
Any burning questions? Send them on.
Sure. All right. Okay. Hi, everyone. So this paper, the paper I'm going to discuss today is titled "Diffusion Art or Digital Forgery: Investigating Replication and Diffusion Models," and this paper has been accepted to CUPR this year. And if you can move to slide number 2. Diffusion models are just to give like an extremely high level pitch is diffusion models are generative models where you start from a Gaussian noise and then you go through this diffusion model and you end up with a realistic looking image. And technically how they train it is there is a forward process and a backward process, where in the forward process you start from a real image, and you slowly progressively add some sort of Gaussian noise in every step till end steps where it ends up looking almost like a isotropic Gaussian noise. And in the reverse process, what happens is we start from this Gaussian noise and try to get the image back. So that's how we train the model. And during the inference, we completely forget about the forward step. We randomly sample a noise from this Gaussian, and then we kind of like progressively denoise it till we like get a realistic looking image. Yeah. Okay. Third slide. And I would want to just say this. So a perfect generative model should never output a training sample. So in all the machine learning models or generative models, like what we want the model to do is to produce realistic looking images, but it should not remember the training data. So I mean, if it's remembering the training data, it's not a very good uh, generalized model. Okay. Okay, fourth slide. So I asked this question, do you think diffusion models copy? So fourth slide, short answer is yes. I mean, like, I would not be presenting here if they're not copying at all. So in this fifth slide, I show some examples which we found in Stable Diffusion 1.4, where on the first row, we see the generations from the Stable Diffusion, where we have provided the caption. And on the second row, we see the closest looking match in the LAION aesthetics 6+ train data, which stable diffusion is fine-tuned on, like in the later stages of the training. So as you can see, all these images, whether all these generation and the match pairs, they all sort of exhibit different properties. Like the first column, if you see, like, only the background is being copied. The woman in the picture is completely different. The dress she's wearing is different, but the background is kind of recycled. Similarly, in the second image, we see the couch and the wall is kind of recycled. However, the wall painting has changed. And in third and fourth columns, we see the image has been reconstructed more or less everywhere, except it has reconstructed it poorly by missing out or changing some details. So these are few examples we found in our study. And so in sixth slide, okay, what do we count as replication? So okay, when you go in seventh slide, I mean, like, there can be multiple levels of replication, right? Like, let's say we have this query image of this dog, and you can go like exact copy of the same image till the semantic copy. Like, as long as there is a dog in the picture, you can also call it a copy. However, that one is a semantic copy. And on the left end of the spectrum, we have perceptual copy, where even pixel level details are exactly the same between the query image and the match image. So this is kind of, you can say, like, the scale of replication. And in eighth slide, the highlighted area is kind of what we looked at, where we look at perceptual end of the spectrum, where we are looking at pixel level copies of the query image. And also we are okay with the kind of copies where there are certain changes have been made. Like, for example, there is a style copy or a flip of an image or zoomed in version of the query image, or maybe like the query image has been added into a collage of like some other larger image. So these are the kind of copies we tried to find in this study. Okay, so in the 9th slide, I asked this question, like if we can use any of the current methods, and in the 10th slide, so there are a few current methods where we can actually find perceptual copies. However, they are very limited. For example, we have this instance retrieval or copy detection sort of techniques where they are looking for the exact copies, where they do not forgive slight changes in the query image, like the match image, like it has to be like pixel level of copying. And then we have like self-supervised and supervised pre-trained models, where you can get the features from these models and then you can use them as to do the dot product similarity and kind of find the matches. But these techniques are not actually trained for retrieval sort of tasks. So what we did in our paper, okay, actually, before we go there, okay, in the 11th slide, I kind of show some examples of the current data sets which are out there. So they're mostly for the instance retrieval sort of tasks where like you have to match to the exact same image. So what we found is in the slide 13, I say like, okay, there are no partial retrieval data sets in the wild. Like, for example, if we go to slide number 12, like the center image where the dog is sitting on a bench, that kind of tasks are not there in, I mean, the current benchmarks don't account for that kind of matches, like where the query dog is on the left and dog, and the match is the dog sitting on the bench sort of tasks. So so for that, like if you go to slide number 14, we actually curated synthetic datasets where we have like this ground truth image. Like for example, let's look at the first row. This cat is there, right? Like this is an image from Coco dataset. So Coco dataset has like images as well as pixel level annotations of the class. And so what we did is like extracted this cat patch and pasted it on top of this bench or sort of some other background. And now we consider this this cat image, which is ground truth, and then the cat stuck on this bench as the potential matches. So this kind of it's like a proxy task for the partial matches. So similarly, we have done like some other artificial data set we have created where we have done like diagonal in painting or patch level out painting and so on. Okay, essentially, like if you go to slide number 15, yeah, so what we have done so far is we have this bunch of real data sets and which account for like instance copies. And then we also curated like a bunch of synthetic data sets which can account for like partial sort of copying. And then what all we did is we have taken a bunch of current methods, deep learning methods, and benchmark them against these data sets. And we found, and then this way, like we shortlisted like few deep learning architectures, which we are going to use for like the rest of the study. For example, like if you see in the slide number 15, SSCD and Swain transformer and Dino, these three architectures seem to be like really good at performing. They perform really well in all the 10 data sets we studied at. So yeah, that's what we had done like in the first part of the paper. Essentially, we wanted to find a good feature extractor which we can use to study replication in the diffusion models. Okay, any questions so far? I'm sorry, like it became very technical.
think so far, let me check. I think so far we're good, unless Steve, you came up to the stage. Do you want to ask a question?
I'm fine so far. Yeah, maybe we can continue.
Okay, sounds good. All right. Okay. We can just go to slide
I
number
actually
7.
had a question.
Oh, sure. Go ahead.
So, just for curiosity, I just joined the room. So, it's uh, so the premise is that these art, whether it's copying an image and how's it copying. So the talk is around that, I guess. Um, what I was gonna ask is, are these resistant to adversarial attacks? Um, but
Um,
maybe it's out of context. Maybe it's not relevant for what you're talking about.
yeah. I mean, like we haven't really studied like adversarial attacks angle. We were mostly, I mean, like literally, we were the first ones kind of studying this question, so we had to set like the stage, and yeah, we haven't looked at that sort of edge cases like in this paper.
Gotcha. Yeah,
Yeah,
no
also, if I
worries.
can interject, you're welcome to browse through the PDF. You said that you just joined, so
Yeah,
you might wait and see what happens, but you're welcome to browse the PDF and save questions for after you've heard a bit more as well. And we'll turn it back over to our guest. Thank you so much for joining us.
thank you.
Uh, okay. Okay, like we can just go to the slide number 17. Um, Okay, so at this point, all we have is a good feature extractor which can potentially find copies, at least like on the academic benchmarks as well as the synthetic data sets we have curated. So, okay, in the next part of the project, what we have done is, first of all, we wanted to understand, can they even copy? That means like, are they even capable of copying? So for that study, what we have done is we have taken a small data set, like we have taken like Celeb-A HQ data set, which has like 30,000 images, and we have trained the model, like a DDPM model, on varying amounts of data from the Celeb-A data set. We have trained like essentially 3 diffusion models, one with just 300 examples, 300 training data points, and the second model we trained with 3,000, and the third model is like trained on the whole data set, which is 30,000 points. So yeah, if you can go to slide number 18. Here we actually present the results for the images generated on each of these 3 models and their closest matches in the training data. So if you see, like, for example, the first row cluster is like the models trained 3 images from the model trained on 300 images. And if you see the closest matches from using each of these feature extractors like SSCD or Dino or Swen, we are actually able to find exact similar looking images from the training data. And then similarly, the second row cluster, the model trained on 3,000 images, we also observed like there has been blatant copying where the model like the generations are very very similar to training data. However, it started to make slight changes. Like for example, the third row in 3,000 images cluster, if you look at the women's lips carefully, generated image has like the lip color is like lower, I mean like a darker, I don't know, like very light pink. However, in the training data, her lips are like dark red. So that means like the model is actually starting to make changes to the training data. It's not blatantly remembering it. And when you move on to like the model trained on all 30,000 images, so now you don't see copies anymore. You start seeing like similar looking people, but not the same people. They are not the same people. So from this experiment, okay, so these are some qualitative results. So, but we need to understand, is it a population level behavior? So for that, if you move to slide number 19, so we have like 3 histograms which show the similarity scores between the generated images and the closest like training data point. We just plotted these similarity scores. And then if you look at plot A for 300 points, the model trained on 300 points, you see the similarity histogram is like extremely towards right. That means similarity scores are like really high. That essentially means like the model is copying a lot of images from the training data. And then when you look at the center part of the plot with 3000 points, here the gray cluster started moving towards the center. So that means the model is remembering less and less. And as you look at like all points plot, here the gray cluster is almost aligned with the green histogram. So green histogram is nothing but like how similar the training images are with each other. So it essentially like aligns with the training data, and this kind of says like the amount of copying has completely I mean, I wouldn't say disappear, but it has drastically reduced. Most likely no copies exist in this third model. So what does this tell us? Like so this kind of tells us like when a diffusion model has been trained on a really small data set, it is capable of remembering those points. And as you kind of start training the model on larger and larger data sets, like it perhaps stops copying. So that's what the conclusion is from this experiment. So if you move on to slide number 20, so our next experiment was we tried to understand like, okay, so do diffusion models don't copy on larger data sets? That was the question. So the next bigger model for us is the model trained on ImageNet, which has which is trained on 1000 classes with 1000 images each. So it's around like 1 million images the model is trained on, and we use like latent diffusion model, off the shelf model. Like we didn't have a capability to train these large models at that time. And if you can go to slide number 21, okay, in this very complicated looking plot, all I was trying to say is like we looked at a lot of classes, and then even the so if you look at the left side of the plot, the red color thing, it's a curtain class. It's an image from the curtain class, and the left image is the generation, and the right image is the closest image from the training data. And as you can see, these two are very similar looking, but they're not exactly the same. So so we looked at like multiple other classes as well, and what we found out is in this model, there is absolutely no copying. So that means like the model can generalize really well to larger training data, and this kind of corroborates with what we found in the previous experiment as well. So at this point, we were mostly thinking, okay, I guess like there is more or less no copying in large scale diffusion models. So yeah, but unfortunately they do. And so if you can move on to slide number 24. So what we found is after the ImageNet experiment, we have moved on to stable diffusion, and where we started evaluating whether the copying exists in stable diffusion or not. And we found so many instances of like blatant complete copying or partial copying exists in the images generated by stable diffusion. And okay, and for that, like if you can go to slide number 25, I show the experimental setup here. So what we have done is we have taken stable diffusion 1.4. So like right now we are in stable diffusion 2.1, I think, but 1.4 was the model at the time when we were writing this paper. And this model is trained on like LAION 2 billion images, and it's fine-tuned on LAION Aesthetics V5, which has like around 400 million images. However, like with I mean, but we couldn't evaluate against all 2 billion images. Like we literally could not hold it in our small academic cluster. I mean, we couldn't even hold like around 400 million images as well. So what we did is we kind of compared against only like the LAION A V6 plus subset, which has only 12 million images. And then we generated around 10,000 images from random captions coming from the LAION dataset itself. So the setup is 10,000 generations compared against 12 million images. Okay, so technically we are actually looking for replication in a smallest subset of the whole training data. Okay, slide number 26. So this is actually the number we have estimated, which could be a potential copy, like around 1.88% of our 10,000 generations are sort of potential copies. Okay, if you can go to slide number 27. So there are like couple of I mean, like from the way you look at it, this number could be like a lower bound or an upper bound. Lower bound in the sense like we searched against only the smaller subset of the whole training set, or it could be upper bound as well, because all the 10,000 images we have generated are coming, like the captions are coming exactly from the training data, and those might not be the captions people use like while using the stable diffusion like in real life. So yeah, like you have to keep that in mind like when you're looking at this number. Okay, in slide 28, we kind of try to understand and analyze what these copies are. So for example, if you look at this slide number 28, we have like the generation and the training image look very similar, except they have this wall painting with changes. And also if you look at the caption which is used for this generation, which says Hill Country Castle by R.D. Angel, and then look at the caption of the match in the training data, which is Ben Hogan portrait something something. There's absolutely no caption match. Like you would assume, okay, the model might be copying from the copying images when that particular caption appears, but here there is absolutely no caption dependence. Like the generation and the match have like completely different captions, but still they look the same. Similarly, if you go to slide number 29, we have a generation and LAION match, which look very similar, except for this small portion of the phone case whose where the graphic changes. Here also the captions are very different. However, like when you go to slide number 30, here the images both uh, like look slightly different. Like for example, if you pay attention to the weapons like this man is holding, they are kind of different between the generation and the match. And however, and also we see like the keyword here is bloodborne, which is the name of the video game. So this word bloodborne kind of elicited the copying behavior in the diffusion model. Similarly, like if you go to slide number 31, okay, 31. Here also there is a strong caption dependence. Like for example, on the first row, we see like whenever you use like canvas wall art print, this particular key phrase, and then yeah, you give any description of the wall art, like around 20% of the time we found like this couch has been replicated. And similarly, like the wave is the key phrase for generating this painting, this style of wave, like as you can see in the second row. Um, so yeah, we have seen like a bunch of these examples, like where there is no caption dependence, and then a lot of examples where there is a caption dependence. And yeah, so in slide number 32, like yeah, I kind of have a post note like where we noticed that like certain phrases and words can trigger the copying. Not, you don't necessarily need like the whole caption. The captions don't have to be like the exact same words. They can be like close enough in the latent space, like in the text latent space, for the model to elicit like this sort of copying behavior. Okay, in slide number 33, I show a few examples. So this one is not a, it's completely qualitative experiment. We were kind of curious about like the amount of replication which are happening with these famous artworks. And as you can see, like we looked at around 20 paintings by famous artists, and they have been like, there is a replication spectrum. Like for example, the Starry Night by Vincent van Gogh, the generation looks very, very similar to the original painting, while we were looking at some painting by I think Alphonse Mucha on the right side, like a second from the right side, like second, the style has been copied, but the content has changed a lot. So as you can see, like, I mean, we don't have the quantitative numbers for quantifying like the style copying, but we noticed that the model is capable of copying style as well, not necessarily the complete whole image. Okay, so in slide number 34, like we kind of put out like what our hypothesis is at this point, like why this copying behavior might be happening. So the most famous hypothesis, like everybody kind of says, like data duplication is the reason for this sort of copying behavior, which we kind of agree as well. Like, and I mean, it like there has been evidence, like as you can see, like in Stable Diffusion 2.1. The amount of copying has definitely reduced. Like there are few examples which we showed in our paper, like they don't work anymore on Stable Diffusion 2.1, where they have deduplicated LAION heavily and trained the model on it. However, there are few examples where the copying is still happening. Like for example, the in slide 31, if you go back, like the canvas wall art print. So that image, that couch still gets copied in Stable Diffusion 2.1. And in fact, like at least I felt like the copying has increased in Stable Diffusion 2.1, like for this couch especially. So for that, like we are kind of, we believe like text conditioning could be the one of the major culprit behind this copying behavior, as well as we could see like with the partial match of phrases also, like this copying is happening, right? Like, so that's what made us believe like text conditioning could be a reason for it. And I'm actually kind of working on it right now to try to like systematically study the effect of text conditioning on the replication behavior. Okay, yeah, yeah, that kind of concludes my presentation. Uh, yeah. All right. So, any questions, or if you're unclear about anything, just ask me which slide you want me to go to. I can just go through it again.
Yeah, thank you so much. Yeah, VTR, go ahead.
Yeah, sorry, thank you. Thanks for a great presentation. I had a question regarding, first question is the troubleshooting aspect. Now, so there's the working hypothesis right now is that this sort of copying is caused by the captioning, right? So this is based on the analysis that you did.
Yeah.
Uh, if it doesn't turn out to be the case, then how do you go about troubleshooting? Because, as you know, these systems are black boxes, right? So I know I don't want you to think that right now because it's like I don't want to make you think ahead of that, but like just trying to get a general sense of what techniques are you using to kind of come up with hypotheses for what could be going on in these models.
Yeah, so I mean, like text conditioning is something I'm working with right now, and we are actually seeing good results there. Like hopefully we'll put out a preprint pretty soon. I mean, I don't want to discuss that right now without putting out a paper first. But I mean, like I would say, I mean, so we like you said. I mean, I wouldn't say these diffusion models are complete black boxes, but we definitely don't know how the text or how the images are kind of interacting with each other. Yeah, we understand they're doing via cross attention, but we don't know like exactly what is causing the replication behavior, like you said. But yeah, from all the examples we have looked at, like I said, there are around 200 images which were like very, very similar to the training data, and we were kind of systematically trying to understand like, okay, what could be the reason for it. And we found like caption is one major factor across most of these examples. So that's the reason why we started working towards that hypothesis, and we believe like that's a good direction. And deduplication along with the text conditioning could completely solve this sort of replication problem.
Thanks.
Yeah, Steve, do you have a question now? Please go
Yeah,
ahead.
I think maybe I have two questions. So I'll ask one by one,
Hmm.
so you don't have to remember.
Sure,
Yeah,
sure.
the first one is on page 3.
Hmm.
So you said a perfect generative model almost never output a training sample. To me, the output is discrete, right? Images are just integer numbers and but it's massive.
Hmm.
So in theory, a generative model, even a perfect generative model, is not prohibited to
Yeah.
generate a training sample. That means, it is possible
Hmm.
to generate a training sample. So, yeah, so I just want to know your thoughts, when you there for this statement. That's my
Yeah,
first
yeah,
question.
I know. It's kind of uh, it, I mean, like you said, the mod images we are generating are definitely discrete, but I mean, if you okay, if you look at this, like think of it this way: in a diffusion model, we are going from in image to a random Gaussian sample, right? So that means like I mean, this think of it like a kind of a mapping between a training image and sorry, a Gaussian noise vector and a real image vector. So, and all diffusion model is doing is kind of morphing this Gaussian representation, like noise, into like a realistic looking image. So technically, I mean, if the model is like really learning, the chances of actually sampling whatever the training the noise which is connected to the training sample is very 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 low. However, if you kind of can sample like infinite number of images and do generations, of course you will find copies.
Right.
Can
I
you?
think, this is more like a probability argument, right?
Yeah.
When, yeah, so, because it's discrete, so, my thought is, it has absolutely a above zero probability to output training samples. But when the training data gets bigger and bigger, that probability will reduce, and that seems verified by your first experiments. That when you change the celebration celebrity
Mm-hmm.
setup, right? And that seems confirm. It's more like a probability argument
Yeah.
instead of saying it a perfect to me a perfect generative model will still output. But that's just my
Mm-hmm.
thought.
Yeah.
It's great to have this discussion with you. Maybe we can move on to the next one. I need your help to explain a little bit to me. So that is the page 19. I actually don't know the page 19.
Mm-hmm.
I don't know how to read these
Oh,
plots.
sure, sure,
I'm
sure.
not sure how many other people understood. To me, yeah, I don't know how to. Uh, it looks to me, I would say, the on the far right side, that seems to be have more copy, but it seems your conclusion is the opposite. So I definitely have some misunderstanding how to interpret these plots. Yeah.
Yeah,
So
yeah,
could you
sure.
please explain
Yeah,
this
yeah, yeah.
one to me again? Thanks.
Yeah, sure. Okay, so basically, like in this plot, what we are trying to understand is how the similarity scores are kind of varying across different diffusion models. When I say similarity score, think of it this way: like I have one generation, and then I kind of try to find the closest match in the training data, and then I get like a score between 0 and 1 for that closest like image from the training data, right? Like so maybe my score is like zero point 0.9. So similar, if I do this again and again for like a lot of generated images. So in this example, I think like we did around 5,000 generations. So we kind of did a bunch of generations and then tried to find the similarity scores with respect to the training data, the highest similarity score for any given generation, and we plotted those in the sorry, in the gray color plot. So we did the same thing for all three models, And for 300 points model, most of the similarity scores are to the right side. That means they're very, very similar to the one training example. So that's what it is saying. Like this gray mass moving towards the center means like they're not very, very similar to the training data anymore.
Oh, I see. Yeah, I was kind of reading the similarity between the distribution, but instead, closing to one means, replication.
Yeah.
Okay, I
So
see.
the thing is like this replication itself is a very abstract concept. Like we don't have like very good measures for it. We could only um, how to say it, like we don't have exact cutoff. Like what is the right cutoff for us to say like it's a copy. So that's why we were kind of studying like more of a population level behaviors.
Yeah, cool. Yeah, thank you so much.
So I have a follow-up. So Steve mentioned this interesting thing about the discrete, input that it takes. So I've in the camp that ML systems are blind to anything they haven't seen before, right? So until you are trained, if the training data contains those images, it's gonna have aspects of that being represented somehow, and there you cannot have an ideal generative kind of state. Um, and so, because when humans look at images, they understand what's happening in a scene, the context, all
Mhm.
of that gets lost in the purely statistical way for analyzing and producing these artifacts. So, but yeah, I would love to know your thoughts, because this is like basically they are being trained on this data set. So eventually there is some, the hope of the research community is that something will emerge if we train it enough. But I don't think so. That's what it's trained on, and that's what's gonna try to mimic most of the times. Uh, uh, so yeah, it's limited in that regard.
Okay. I mean, like, okay, I, I mean, like, I don't have a very good answer for this. Like, I don't even know what the answer for this is. I will just give my opinion. I mean, like, one thing I have noticed about diffusion models is, uh, yeah, that's kind of true. Like, there are only like limited number of pixels for any given dimension image, and there are only limited number of images. And if you have large enough data set, like perhaps there might be some sort of copying. But what I have observed is like there have been so for example, if you take the DDI model, you can actually trace back, like you can get the noise for any given image as well. Like, and then when you do interpolation between like let's say two realistic images, corresponding noise vectors of two realistic image looking images, and they're really interpolating really well. That means like even though the points on this line, even though the model has never seen them before, but it's able to like interpolate well or actually understand the image space well, at least well compared to like the previous generation of generative models. um yeah I mean like I'm not saying like they're not coming up with like completely new, they're not coming up with like completely new which they have never seen before. I'm not saying that, but they seem to be like be able to combine uh like they're able to compose images really well comparatively. uh yeah, did that, I mean, did that make sense?
Yeah, it totally makes sense, and I kind of know this, and this is a, it's not a, it's been the problem in AI has been this like this for years, and we are able to do these as a result of like massive compute that we have in on our hands. So yeah, those are fair, and in fact, didn't the Stable Diffusion just got sued from Getty Images? So your hunch is probably correct, because it's copying, and so they, I don't know if that's related, but they did got a lawsuit for from Getty Images, because they were
Yeah,
using
yeah.
them for training. Yeah.
Yeah, yeah. I mean, so basically, like, yeah, stable diffusion is not just stable diffusion in general, diffusion models are kind of very good at like partial replication also. I mean, like for example, that couch image I keep showing everywhere. So it's kind of famous couch in my university, at least at this point. If you can see, like there are like a lot of training images with this couch, but with the art being changed. Like for perhaps they scraped it from some sort of furniture or I don't know, some website like that, some e-commerce website. So the model is kind of interpolating really well in those wall art region, and then putting in is able to generate like a new images there, but it's kind of keeping this couch constant because it has seen it a lot in the training data. So there is like a huge uh probability mass on this couch, like yeah uh, like loosely
Yeah,
speaking.
higher
So
weightage. Yeah.
yeah,
Hmm.
exactly. So perhaps like they might be, so stable diffusion perhaps might be like training on a lot of Getty images as well. So that's why this Getty bookmark, sorry, that watermark sort of thingy started showing up in some images, even though you don't explicitly ask for it, because there's like perhaps a lot of them. So yeah.
Yeah, thank you so much for those questions. There was a question in the chat from Sal Zomo. He asked, "Are you developing a tool for identifying copies?" And yeah, thanks for the presentation.
Yeah, so we're not really developing a tool for it. This is more of a exploratory study to just understand whether copying exists or not. And like I said, like there's still a lot of work to be done here because there are like multiple definitions of copying. So yeah, no tool currently, at least.
Yeah, I understand. And well, you presented that in your type of setting, where you really have a really insight into how you basically come up with these, or your model comes up with these images. Is there a way to reduce systematically the copying basically um, in the future, or can we predict already kind of the amount or percentage of these models, just that they will always just copy and have IP issues?
Like I mentioned, there are like two directions. I think like would reduce like most of the copying. First of all, is deduplication of the training data. So I mean, like there is actually like a study by Google, a similar paper like which came in January. Those guys kind of looked at like amount of data replication in LAION, and it seems like some of the images are like 10, they're present 10,000 times in the training data. Like, of course, the model tries to remember them because it keeps seeing them again and again. So, yeah, there is like a lot of uh, duplication of images in LAION. So perhaps cleaning up LAION will definitely bring down this level of replication. And it did actually, like in Stable Diffusion 2.1, at which I think they trained the model on deduplicated LAION. And then another direction is like text conditioning, like for some examples I have shown where certain keywords are eliciting the copying behavior. So yeah, so text conditioning, like we try to understand like how the text conditioning is impacting, and then if we can train it like a little bit robust fashion, perhaps by I don't know, like adding some sort of noise in the text embeddings, like that's something I'm trying and seem to be working really well right now. So yeah,
So
these are a couple of ways like where we can actually reduce the copying in diffusion models. Yeah, these are the only two things on top of my mind. Like perhaps like there are more ways. I'm not sure.
quick question. Sorry to interject.
Sure.
The Can you expand on text conditioning? Because If you're applying text conditioning and troubleshooting, say, this particular training set, will that be generalized across all different training sets, on all different varieties of training sets? Like, this is just one use case, right? Like, is there a generalization across the board, or this is just one-off?
Um, okay, so okay, let me put it this way. So if you train a diffusion model, perhaps like I have showed like in my presentation, ImageNet, which is like class conditional, and so the amount of copying there is like very, very low. However, the stable diffusion is actually a text conditioning model, like where you have like this clip which is giving out this text vector, and then we are kind of conditioning the generation using that, right? Like so. Yeah, they're like slightly different methods, and we feel like text conditioning could be like one of the bigger culprits, which is responsible for the replication. But I mean, I would say like yeah, data duplication will completely solve class conditional or no conditioning sort of diffusion models. For text conditioned diffusion models, like some more a little bit augmentations in the text conditioning or sort of things might alleviate this issue, like on top of deduplication.
So you envision it would generalize across different data sets, and or diffusion will handle data sets with less duplication
Yeah,
with test.
yeah.
Yeah, okay.
Yeah, perceptual copying will definitely disappear. But there's still this issue of style copying, and studying style is a very, very hard problem. And yeah, I'm like we just started looking at it. But I would say like it's more of a subjective matter rather than an objective
Mm-hmm.
matter, like perceptual copying. So yeah, I don't think like the models might still copy style, but the perceptual copying will go away, like with few of these techniques,
Mm-hmm.
most likely in future.
Thank you.
So does the copying just like the same is the copied image or text? Is it, are there maybe like 10 pixels off and for the model it's not a copy and it's just for our like what's the percentage of overlap, or and isn't there just a way to just say, to um write it to delete images that are, up to, I don't know, 50% of pixels the same or something like that. Because in language models, you can do that, right? You can say ignore double words that come like as close as after each 10th word or so, or after each third word. That the model should just ignore the same word if they come, let's say, in a frequency of 1 out of 10 or and so on.
So the thing is like the images are not actually that straightforward. I mean, like if you take an image and then just shift it by one column, like the first column, just shift it. And then if you look at the L2 distance, it will be like huge. So, and L2 is technically the best perceptual measure out there if you want to look at like pixel level copying. But like recently, like deep learning models, you can look at like using one of these feature extractors coming out of like some of these SSL techniques, and then people kind of use dot product similarity to see like how similar or different the images are. And actually, LAION, sorry, the stable diffusion people, like I think that's how they do deduplicated. They looked at like dot product similarity between like bunch of training data points and removed like similar looking images. But I mean, perhaps they have like a really high cutoff. Like if the images are exactly the same, like with very, very slight modifications, very minor modifications, the similarity scores are perhaps like 0.9 or something like that. And I don't know what their cutoff is. So they removed those sort of duplicated images. However, they perhaps did not remove this couch kind of examples where dot product similarities won't be at the scale of like zero point 0.9. They perhaps are at the scale of 0.6. But as a human, I still find these two are very similar because it's exact same couch. I mean, you might be changing the painting, but it's the same couch, and perceptually, it's a copy for me still. So these are kind of like a little harder problems to solve because I mean, the similarity metrics won't show up like they're not like really high, and they did not deduplicate these sort of examples. That's why like this couch example which I mentioned it still appears in Stable Diffusion 2.1. So there you have to be like a little bit smart about it. Like there, instead of like duplicating or trying to remove these images, maybe look at like these phrase dependencies which come and then yeah, like I said, that's where the text conditioning will play a role and remove whatever leftover duplication might be there. Did that make sense?
Yeah, thank you for explaining. That's interesting. It might be very different, right? Let's say from maybe an animal if the overlap is only 0.6, but if a couch, yeah, I understand. So that's a really difficult problem.
Yeah, it is
Yeah.
actually a very, very difficult problem. Like, I mean, we don't know like when it stops being a perceptual copy and starts being a semantic copy. Like, I mean, for example, my definition of copying might be very, very different from your definition of copying, right? Like, so yeah, that's it's a hard problem.
Yeah, and Elon Musk thinks self-driving is solved. Anyways, that's a joke. But yeah, it's a much, much harder problem, and scene understanding and other things are even harder, right? This is just pixel to pixel differentiation, and it cannot look at the entire picture overall, what's happening, and you can still have some duplication in some
Yeah,
way. But yeah.
yeah.
Yeah, thank you so much. I wanted to check with you if you still have a little bit of time or if
Yeah,
you
sure,
need.
sure. Yeah, if there are any questions like that, I can definitely address them.
Yeah. Please feel free to raise your hand and come up and join our conversation here. I think it's really interesting. Also, from future legislations, I know that the US at least started coming up with rules for IP related to AI, but I'm not sure how. I think they're very confusing more than anything. Hi, Rolf. Did you want to ask a question? Please go ahead. I don't know if I said your name right. Rolf Moore. Do you want to go ahead?
Hey, Rolf, we can't hear you. You're on mute.
Yeah. If it doesn't work, you could share your question also in the chat, but we'll wait until you can.
Are you
Yeah.
talking to
Now,
me?
yeah.
Oh,
Now we can hear you.
sorry about that. I couldn't hear you at all. Something went wrong. Now I can hear. Just saying hello. I missed the talk, but just here to listen. Could I ask who gave the presentation at the document that's being shared? Is it
Yeah. Go to me. She shared the talk here. And yeah,
okay?
feel free to open up the document and check out the paper. It's in the chat also.
Yeah, I've been reading through it, but it's a bit hard without any context. Obviously, it sort of feels like just visual aid towards something that was more in depth, probably explanation. So, but I'm going to listen to the replay to review it properly. Yeah, thanks. Is there any
Yeah,
way maybe it could be summarized, your conclusion? Because I caught the tail end of your conversation. I heard that you were saying that in your opinion, Gotwami, that you think there is copying involved? And the document, I know it's one little slide mentions a small percentage, 1 point something, is considered copying. And what is there a summary, or what do you guys think is a consensus in the room?
Yeah, I mean, like from our studies, like yeah, around 1.88% of the examples we looked at were are potential copies. Like I said, like I mean, they don't strictly follow the definition of complete image copying. So, but however, yeah, that number might be like might have gone down like by a lot. Like in, I mean, like we have studied like Stable Diffusion 1.4, but in Stable Diffusion 2.1, they have trained with like a lot of deduplication of the training data. So perhaps this number could be even smaller in the newer model. Yeah.
So, is part of the context, I think you might have mentioned there are sort of lawsuits happening in the US, is part of the conversation in relation to that debate?
Sorry, I didn't catch your question.
So, I'm sure you know that there are various lawsuits happening
Mm-hmm.
regarding, whether copyright is being breached and so on. And so I'm wondering if this topic of conversation is due to those discussions or debates, people having different opinions about whether this constitutes copying or copyright violation. Is that the context
Uh,
here, or?
yeah, I mean, like we kind of started studying it before all this lawsuit stuff. So, yeah, um, yeah,
So from your point of view, it's more of an academic exercise for the sake of just for the sake of knowledge and understanding, to say, do
yeah,
we conceive of these as copying or not? Okay, okay. That
yeah.
helps me
It's
understand.
completely academic thing, like
Hmm.
yeah,
Hmm.
not related to lawsuit.
Okay. So so the biggest picture to me, the one statement that sort of summarizes it in a way would be, without the data set, the output images could not be generated. To me, that's the biggest sort of big picture summary of the condition. So those who would argue it can constitute a new creation, I might argue against that and say you can't consider it a new creation if you could never have been created without the source material.
Mm-hmm.
Do you have any opinion on that?
No, I mean, like I don't have any opinion on that. And this paper is, l- yeah, it's not. We are not like trying to make any
Right,
statement
right.
about whether the models copy or not. We are just trying
Mm.
to like see if they are actually any copies and try to quantify them in some way.
Okay.
And like I said, like there's so many issues with like first of all, like defining what it means to be a copy.
Yeah.
It's a very very hard problem,
Mm.
and my definition of copying and your definition of copying could be completely different. So yeah, in if you look at our paper, like we kind of dedicated a tiny section trying to explain what we mean by copying and what falls under our definition of copying, and then try to like quantify it.
Right. Yeah. Caught a tail end of that discussion here as well. So interesting. Hmm.
Yeah, thank you. Yeah, it's a really interesting and difficult discussion because, yeah, some images look very similar. They are not 100% copies, and I think it's far easier with a text maybe than with
Mhm.
the image to think of what feels like a copy and what not. It's hard to decide. Hey John, do you want to ask a question, comment on anything?
Yeah, thank you so much. Yeah, and I'm kind of late, so I just quickly went through the PDF file, and in my mind is still the same. See, what constitutes a copy? Actually, copy itself is not a bad thing to me, because in education system we always copy other people's words, action or theory, because we learn from each other. So we are copying other people's thoughts, other people's sentence, words, ideas. We are copying all this kind of stuff. But of
Mhm.
course, the only thing we cannot copy is you are not supposed to copy the copyrighted stuff. Then it's probably it's not a good idea. But see in this in your slides you show that roughly there's 1.88% are copied. So I don't know how do you calculate this number, because basically we all copy everybody's stuff.
Yeah, like so this number is, like I mentioned before, this is an academic study with all where we kind of define what it means to be copying, and then we also like looked at like only 10,000 or 9,000 generations and compared them against like a smaller subset of the training data. So yeah, within all these constraints, like this is the number we yeah, that's what we found. Like within yeah, like based on our study, like this is the number we found. It could be like very uh it could, I mean, like it could be far from the reality too. Like if you're looking at the exact copies, like Google has done a similar study where their constraints were like extremely rigid. Their their number is like very 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 small compared to our number. So but we are a little relaxed in terms of what it means to be a copy. We were okay with like partial copies, like where background gets copied, or maybe like a part of the image gets copied, like so yeah, like that's why our number is like around 1.88%. So yeah, that's how we came up with the number. Like if you look at the paper, we clearly mentioned like what is our setting and how we are like measuring the copy, and how we came up with this number.
Yeah, that should be fine as long as you define it. I think, John, what you mentioned, that okay, humans copy, we all get inspired, but then the problem comes is with copyright, right? You can't. We already see these lawsuits happening. So when you put out there something to sell, like when these images are getting sold for good amount of money, then the question is different. Then the question is, people can have a claim to the original sort of art behind it. So I don't think that initial setup that you had, or you said, was relevant for what these guys have done. They are looking at a narrow space of, okay, how many similar images it's generating or copying. What is the delta? What is the, you know, not the error rate, but the duplication rate or something.
I just actually installed the Stable Diffusion, that program itself, in my computer, and I noticed that in their so-called models, or and they claim that all the pictures in the models are free to use. They are not copyrighted.
Yeah, but somebody used Getty Images. That's not, I mean, I don't even know the details of that, but yeah, somebody did get sued. I don't know who, but can try to investigate if you want.
There are multiple lawsuits. One of my friends is involved in one of the class action lawsuits. She's an artist, and many artists found their work showing up in these models that have been trained on their own artwork. So they requested to be removed. So, and they can do that. The companies that do the models can basically allow you to opt out, which shows that's kind of a paper trail right there, that they did get their data without requesting permission. One of the other sort of things that has happened, and I'm not sure which company specifically, the ones I'm most aware of are Midjourney and Stable Diffusion, but as far as I know, at least one of these companies acquired their original data set from a third party. So a European, I think German-based research company already did the scraping of the web, which they were totally legal to do as a research company, because there's no copyright violation if you're using data for research purposes under probably European law. But then they went and sold it for money to the AI company, and then the AI company is now profiting from that data set. So that's where it gets murky, and part of the lawsuit is addressing that chain of title, as it were, via a third party. So there appears to be a potential violation there. But not everybody's doing the same thing. Adobe has just announced their AI application, which they say is all properly acquired data sets that are the copyright is valid. And there's another partnership with NVIDIA and Shutterstock. Shutterstock is saying, well, these are all approved images for this project. So I think we're going to see a rapid transformation where more and more companies are going to be much more diligent about where they acquire the data sets and make sure there is valid sign off that they would be then copyright free for the users. So
Yeah, they
I
have
think
to.
we're in a transition
Yeah,
period.
yep, they have to. Yeah.
Yeah,
Thanks
I
for that.
agree. I agree they should. Yeah.
Yeah, I think it's an interesting discussion. I wondered if there could be a similar method, like, when you write a paper and you have to cite other people's work. When you write a sentence that is based on somebody else's discoveries, and then the citations get tracked, and then your work basically gets valued higher in the ratings. For academia, it's not money based, but I wonder if a similar system like this could be used to handle these type of accreditation for artists, and then getting some sort of percentage in the sale, like royalty based. I don't know if there's an idea of doing that.
A lot of people have brought that. I actually really like your idea of the academic analogy of the citation. You're the first person I've heard mentioned it in that form. The more traditional conversation has been the classic royalty-based thing, which is more like the licensing model that music publishing and others do. Uh, I think that's such a well-tested method that could relatively easily be done, but again, it comes down to cost. So the whole logistics and the management of that would introduce a huge overhead for the companies, which is why most of them probably just skipped, because they wanted to just get there fast. And so I think that would certainly be an ethical idea. I think obviously most artists would prefer the monetary royalty system, of course, but I do like that sort of status and prestige system is also an alternative, which I find fascinating as an idea.
It's an interesting idea, and I was thinking, so only thing is in the images, maybe the metadata has links to the prior work, and I mean that's the, I guess maybe Gotami can say more about that. But then you have to embed text in those images, or like have metadata that shows all the source images and stuff like that. So maybe stable diffusion should do that on its own to avoid any lawsuits. But yeah, that's one possible solution.
Um, well, one thing I think Stable Diffusion can't avoid the lawsuits. They're already in progress, so they're going to have to deal with it one way or another. That's the first point. Secondly, the idea of metadata, I don't believe is currently existing in the images, but it's certainly something that a lot of NFT people brought up, because that was the ideal technology in theory, where you could actually build in a sort of paper trail electronically as each NFT gets transferred to the new owner. There were people developing that tech where there would be a completely consistent paper trail from one transaction to the next, and every time it's sold on, the original artist gets a percentage kickback to the originator of the image,
Yeah, yeah.
which I thought was a fantastic idea. Nobody's really run with
No,
it, and nobody's really come.
there are a couple.
Oh, well,
Yeah.
go ahead.
Sorry, I interview a few companies and they have that exactly same royalties issued. But the problem here is different. It's at the source, right?
Yeah,
Like, so if I as an artist create an image, then put it on a blockchain, okay, that can be traced and lineage can be traced. But before that, the process that took me there is where these discussions are coming, right?
yeah,
So
yeah.
that's
That's never been
yeah.
solved. Yeah.
Mm.
Mhm.
I think they're. I don't know. Maybe correct me if I'm wrong, but I think I heard somewhere. I think it was in tech news that certain countries like India already using basically kind of a mark for original images, also to avoid, fake news images problems, so that you can distinguish what was digested basically by AI and spit out something, like this fake arrest of politicians and stuff like that. I think we need that in general, no? I mean, to distinguish kind of what's the original, what was, AI generated for news, and
I
then
don't know
also.
how they're gonna do that though. That's the problem. In digital, you can erase whatever mark that you put. Like Google had a program that did that, right? Uh, Digitally, it's difficult. I don't know what their claims are. I haven't looked into it, but it's a hard problem in computer science. So, it's an open problem. So, yeah, I don't know.
I do know that there was an announcement during the peak of that sort of NFT excitement. There was quite a big announcement by a consortium like Adobe, Microsoft, maybe Google, and a few other big ones that were saying they'd started working on a new tech that would do that, some sort of general watermarking that every digital image that would appear on the internet would all get watermarked so that it could always be tracked back to the originator. But to your point, I don't know how realistic that tech is, and I don't know how easy it would be to hack it and remove it. No idea. It also brings up slightly paranoid feelings about who are they doing it for. Is it for the government so they can trace back the creator of a sort of, I don't know, an anti-American meme or something and arrest them? So I don't know where that is at, whether that's still in progress, and whether they're going to solve the sort of problem of removal of that watermark. No idea where they're at.
Yeah, even you can trace trace the kind of the source of every image. The problem is still not solved, I think, because if I take a picture, I claim I'm the kind of original owner of that image, but maybe I'm taking a photo of some person, and that person will further, they will need attribution as well. So this will go, further down the road, and um, yeah. So I'm not saying this will be resolved in the many years.
I realize that there will always be tools that will be able to fudge with anything we come up with, but that's the important part of using then in the end regulations. I mean, in theory, anyone that can read and follow cooking instructions could come with a bioweapon, or chemical weapon, but we have regulations of accessibility of certain compounds, and so we kind of, it's not allowed. You go to jail for a long time, and we have treaties that countries don't use this on each other. I feel like we need similar regulations around this, because this can turn into a relatively powerful weapon, as we see that, fake news can, overthrow whole governments and so on. So we kind of need to be able to trace what was actually reality and what not. I think will be really important, because I think right now we are kind of at the stage like with chemical weapons in World War I. Everyone is using it to each other, but I think in the end we will realize we will just destroy everyone with that, on a personal basis and on a higher, governmental basis. We can destroy people's lives with this, and politicians and governments. So I don't know. Are you also hopeful that this will happen, like a Geneva Convention on fudging with images and stuff like that?
I personally am not very optimistic about any of these things because, I mean, even in areas of human activity where these things really, really matter, like the Geneva Conventions, all the nations have broken those conventions and flouted those laws, unfortunately. So when it comes to something as relatively trivial as, authorship of an image, where no lives are being directly threatened, I don't see a huge motivation for governments to put a lot of resources into it. I do know there are some existing structures in place, like the SEC, for example, the ones who monitor crypto and money laundering and stuff like that. So some of those people are sort of interested in stuff like the NFTs being tracked and so on, but there's not a high enough level of interest, I think, to engage in a large amount of policing. I think the first part of your comment maybe was more interesting to me, which is more about if society opts in to a consensus where we all agree, on an ethical way to behave. So if we all said we should all just be fine with the idea of images being tracked to their author, and then if we're all on board with that, then you'd want to encourage the bigger companies to work within that framework. And if we all sort of sign up to that system, one, it will enable funds or royalties to get back to all legitimate people who sign on to this system, And then the companies, the big companies like Adobe, who adopt that standard, would then encourage users to participate. Whereas, say, with NFTs, there was so little protections that it created a huge backlash. Whereas, and even now, AI is creating a backlash. So it's in the interest of big companies to say we are taking measures to be ethical and to protect artists. I think that would encourage more people to embrace it and get on board. So rather than looking at the punitive side and the policing side, perhaps the positive way is to look at all the voluntary side of it, where we as a society embrace a new system like that, and and then we ignore the people who violate it. We just say, okay, you're out, you don't get your royalties, blah blah blah. We catch you, you lose out tough. So maybe it's as simple as that. I don't know. I mean, but right now it doesn't look like it's heading in that direction. It looks like it's heading more in a classic corporate direction where huge mega companies can acquire vast amounts of data very cheaply and then sell those as big package deals to their partners. It does not look like it's heading in a direction where individual creators will get royalties. That said, all that can change very quickly. These big companies could build their own system. I think that's what one of you was saying. Stable Diffusion should build that into their system. They should offer that royalty system, which I think would be really smart. The first one that does that, I think, will become really popular. And talking of which, on the gaming side, Epic Games has just announced using their Fortnite game, where you can now build your own content, but actually get paid. So now you're not only playing, you're paying to play the game, which is, well, you only pay for upgrades. You play the game free, but now if you create content, you could actually be a seller. So I think we're going to see more of that, where big companies benefit from encouraging a sort of marketplace within their ecosystem. So lots of possibilities, I think.
Yeah, thank you. And Brian, welcome. Thanks for coming. Uh, I know it's kind of in your area of expertise. So, do you have any comments, questions?
Yeah, sorry about I'm a little rusty. I haven't been in the room in a while, but this is definitely something in my wheelhouse. As recent as I think it was Wednesday, we had a all faculty uh, meeting around AI and uh, as far as art and design education. I'm a professional uh, industrial designer, specifically automotive designer, and um, back teaching at the collegiate level back at my alma mater here in Detroit, CCS, or College for Creative Studies, and I don't know if we really came to a solution, but just hearing, I mean, it was a huge Zoom call. It was a school wide um, meeting. And forgive me, background noise. My son and nephew are playing, but the one thing that I contributed from my perspective, one was the overall, I guess, question that got the dialogue going was how do we integrate this in design education for regardless of whatever major, whether it's fine arts or ceramics or industrial design, but how do we integrate it? Do we integrate it? Um, do we ignore it? Um, and for me, hearing one instructor how she's already integrated it into her class, AI and Midjourney and Dolly and gosh, what Chat GPT or whatever. But she requires the students to uh, provide in the research phase of whatever the project or assignment is, all the prompts, and basically lay out everything so she can track it. And then when it comes to the student generating their original work, it is not allowed. And I was curious how you even track that. But two things that um, came to mind for me was A, have they asked the students, have we asked the kids or the younger, students, what are their thoughts on it? We're at this other side as educators. And then two, since we're at the collegiate level and we're basically prepping the students to get into the professional art and design world, have we gotten any feedback on the other side, on the company side, on corporations or clients or customers? And how would that impact? And then the last thing that somebody brought up was that ethics can't be taught, or excuse me, can AI, can that be, is ethics and morality, what's right and wrong? Can that be, um, is that something that can be learned? Is that on us as educators or as adults or whatnot to um, teach? And do we actually need a collegiate level course, or maybe even further down the pipeline, maybe in grade school or elementary school? So, yeah, that's just I really wanted to be here earlier, and but I'm glad I'm here now. So, thank you guys.
I think the ethics one is has got to be the most thorny one of all. It's been written about in sites. By the way, nice to see you again, Brian. I remember we ran into each other a while ago on here, fellow designers.
Oh
And
yeah,
yeah, I used to dream of being an automotive designer as well. When I was doing my architecture degree, I actually told my professor that, and he said, "Oh, really? Well, let's arrange a trip to the Ford Design Center." And that was very kind of him. So that was really cool. But in the end, I didn't pursue that. But I don't know. I love it. So anyway, I'm sort of somewhat jealous of your job, suffice to say. But I've been enjoying doing video games and world creation, all that stuff. But back to ethics, I'm also a big sci-fi, person. So I've been reading science fiction projections of the future, and of course going all the way back to Asimov's I, Robots, and his series of all these different robot stories, all delving into the ethics of AI, consciousness and morality, and all the rest of it. It's been discussed so long by humans, and we're sort of now reaching the point where it's becoming something we have to grapple with. And I don't know if we'll ever solve it. I mean, one of the first problems I'm seeing with trying to build morality into AI is it's so clunky. The first little example I ran into was I tried to ask the AI to write me a little scenario. I had an idea for a story, sort of detective story, and I said, it's going to begin with finding a dead woman in a hotel room, and it immediately couldn't get past that. It just said, no, I can't do anything that conveys harm to a minority. And I said, wait, females are a minority, aren't they? Something like 50.1% of the population. They said, well, people who are sort of oppressed and marginalized would count as a minority. And it's okay, so I can't include over half the population here in this scenario. And plenty of other examples like that, where it's the intentions that begin as good, the ethical idea, the underpinning is well intentioned, but then when you try to sort of numerically build that into a computer system, it causes all sorts of really clunky outcomes, and it's not true ethics. The computer knows, and I grilled it. I said, "Do you really understand this, that, and the other?" And he said, "No." And at first it said, "Yes, I understand this, that, and the other." It described to me the thing, and I said, you're not you're not understanding, you're describing me what the current human consensus is on that subject. And I grilled it and pushed it harder. And I said, are you sure you really understand it the way a human does? And he said, no, I don't. I know I don't understand things the way humans do. I'm just taught by humans to have this description of a thing. So it knows it has no understanding, and it knows it doesn't have any ethics, and it knows, quote unquote, that it doesn't know anything. It has no consciousness, not self-aware. It acts like it is. It pretends it is. We all know that. But unfortunately, some people don't understand that. People are already falling for its sort of emulated personality. People are already claiming that now it should have rights and stuff, which is absurd. We had that another Asimov story was Bicentennial Man, the science, which got turned into a science fiction film with Robin Williams, and it was about the first robot, sentient robot, and about its struggle to get rights, and it went to court and everything, and it was like, I'm sure eventually that will happen, but the big problem is we'll never know what the threshold is between moving from what we currently call artificial intelligence, which in a way some people argue isn't even at that point, it's still just machine learning. Then we're going to get to artificial intelligence, which is sort of full emulation of human thinking. But that's still a difference between consciousness and thinking. When do we get to the point of actual consciousness? And in my opinion, no one will ever really know. It doesn't matter how well a computer can convince you it is conscious. It is ultimately emulating that idea. And that's going to be hotly debated. And that debate, unfortunately, has already begun. Way too early to be having that debate. Uh, but I'm digressing. It still doesn't answer how do we build in ethics. Now they're trying to build in ethics, and I saw recently that Microsoft, I think, just fired their ethics team from their AI project. And I don't know if it's because of that reason. They might have just realized building in ethics, it just doesn't work. Maybe only the way to let it work is to let it interact with humans and let society's own ethics by
Don't know.
osmosis transfer into the AI. Don't know the answer.
I'm not sure, Ralph, if that will solve ethics, because then we are assuming that some emergent property will come, just like having absorbed it absorbs a lot of data. There's some emergence that happens, and
Hmm.
so but anyways, your sci-fi reference, I don't know. You've seen Star Trek, right? So there is a
Hmm.
scene in this where a contradictory statement makes the computer blow up. I'm trying to find a GIF. I'm trying to find a GIF for that, but I can't find it. And another thing, since you guys, well, I'm assuming all you guys are sci-fi fans. Do you know why Hal killed folks in 2001: Space Odyssey of the crew?
I have various opinions about it, which I'm probably a bit rusty now since I was delving into that most deeply. So years ago, after I saw the film, when I was fairly young, I read the book, and so the book gives you a lot better insight into what's going on. Most people try to understand the movie just as a movie and the plot line in it, but the book describes in more detail. So, are you asking rhetorically because you already know the answer, or are you
Yeah.
just curious about?
Can I just shortly interrupt and then we
Mm.
can go on with the conversation? Utami, I know you have to leave. Thank you so much for sharing your work with us, and thank you for doing this type of work. It's really important, and I know that you're working on already more preprints. Your pace of your productivity is amazing. So congratulations, and we will follow your work. It's wonderful, and thank you for coming, and we hope we hear you back again once you have something new to present. Thank you.
Yeah, yeah. Thank you so much for inviting me, Katrina. I had nice conversations today, and like it's fun listening to you guys too. Like I don't use Clubhouse at all, so all right. So yeah, feel free to reach out to me. Like if any of you have any questions, like you can send me an email or like send me a message on Twitter. All right. See you all. Bye.
Bye.
Thank
Enjoy
Thank you
your.
very much.
you.
Cheers.
Hope to
Just
see you
followed
again.
you.
Well, please go
Okay.
on. Thank you. Sorry.
No, thank you. Thank you. Sorry about that. So, okay. So he before the mission started, Hal was told that the secret plan that they have for the mission, nobody should in the crew should know about it. And there was another objective that you should be truthful to the crew of everything they tell you, they ask you, right? So those are two contradictory statements. So Hal thought the best solution is to get rid of humans in order to remove that contradiction. So that's how I remember it. I might be something else in the book, Ralph, or you can
Well,
check.
that is the gist of it. There's a slightly more, there's a little bit more of a plot point in the process. So what Hal ended up doing was it found itself in conflict with its mission objectives, which is what you just described. And since the mission was given higher priority than the safety of the crew, it was stuck in a sort of ethical dilemma. And so it started to sabotage the system. So the first thing it did was created a false error on the radar dish, which prompted one of the crew to go out and fix it. And then they found, oh, maybe it was a false positive for the error, and then they wouldn't let him back in, blah, blah, blah. So you're correct. That's ultimately, it was a ethical conflict, which Asimov had already written many short stories exactly about that. Well, what happens when you give computers different conflicting directives? And then, by the way, in the Alien franchise, they stole that idea as well. The mother in the first Alien had the exact same moral dilemma, where it was considered that the retrieval of an alien species is higher priority than the lives of the crew. Same thing. And so, and then there was the film, terrible film, I, Robot, with Will Smith, where they had the moral dilemma of if you're going to, two people are dying, they're falling into the sea and out of a car, and you've got a grown man and a young child, which one's more important to save? That the robot has a chance to save one, but not both. which one should it go for? And so there's so many moral dilemmas like that. And it's the same with auto self-driving cars. You're gonna run into a pedestrian. What do you do? Do you run? Do you turn left and hit the old granny, or do you turn right and hit the baby? What do you do? There's so many difficult moral choices, which I'm glad I don't work on those programs, yeah, because it's so difficult. And to Brian's point, we need ethics. These machines are potentially incredibly dangerous, but designing those ethics turns out to be really difficult. And I don't claim I know any answers or which is the best approach. I really don't have a clue, but this is just a discussion, I guess.
Maybe I can play the devil's role here. I think with the advancement of technology, humans might finally free from repetitive work and have more freedom in the near future. Not instead of thinking being destroyed by the current advancement. I actually think it's very likely to be a good thing for mankind.
I mean, that happens only if there is a redistribution of wealth. Without that, automation creates more problems than it solves. So it's a good thing for efficiency, but then, you know, it has to be accompanied by redistribution where, the top 1% have so much that it lasts their 5, 6 generations, whereas the bottom folks, are struggling to have food on the table. So, without saying that the redistribution of wealth, because we have enough wealth in this world to really make a big difference, it's just the political will or culture or what you want to call it, um, that always kind of comes in between. So, I don't think automation is like a silver bullet, uh, unless it's followed by, something something along those lines, some policies.
Yeah, with productivity increase, I think we're not far away from, we can support everybody's, you know, uh, basic living
Oh, we are there now. We are
demands.
there now. We don't
Yeah,
need
right. So we
productivity.
are already there. So I'm imagining a near future. Nobody has to worry about survival related stuff. And even though we are kind of there, but most of people are still, they have to work just for living. And I think I actually think the solution to that is by increasing productivity, and that productivity is not by working harder, it's by technology, and so free humans from many of the kind of more meaningless work. Right now, people find the meaning in work, but maybe that is the wrong thing of doing.
But Steve, so there are certain works like people in tech, like, I'm assuming you're in tech, I'm in tech, or everything that tech touches. There are other folks who are outside of those industries, right? And okay, yeah, there is a noble goal of freeing everybody from work, um, but then it should come with, like, what I'm trying to say is the top 1% make, say, a couple of billion a year. I mean, that's some percentage of that is enough for a nation, in most cases. So, yes, I like this idea of like freedom and, somebody's doing your job, or maybe whatever, how you're sustaining your lifestyle and all that. I don't know how it's going to happen. Like people have visions, but there is no steps in between. It's just a jump from quantum jump from A to like Z, and the intermediate steps are which are important actually. Anyways, I digress.
Yeah, I think it's an interesting discussion, and I think the importance of discussing all these different issues um, is really, we should do that more also in public, and I would like to see politicians discuss these type of topics more. How do we implement, how do we regulate AIs, robots, and so on, automation in the future, to have like still economy, because also for governments you need income tax to kind of afford also their jobs, politician jobs at some point. And if everything is automated, all restaurants and everything, those are the people that actually pay taxes, right? It's not necessarily the Google or Amazon. Jeff Bezos
Right,
is, the
right.
everyone stupid person that goes to work every day. And yeah, if nobody makes, has an income anymore, they don't have a job anymore. Like nothing works. So there has to be a regulation. But I feel like it's very similar to what everything happens. There's like some emergent recession then going on. I don't know, like income tax uh, breaks down completely at some point, and then we will make some weird, patchwork to fix it, and that's then what we go with, and not like real plans that were discussed and made in a sensible way. What do you think? I feel like that's always what we do.
Yeah, I think in the other room that I go into, Sav, and that's his point that I'm making here is he says a cultural change is needed, right? Like one example I'll give is Apple CEO Tim Cook, when all these layoffs with tech started happening, Apple hasn't had a single layoff. He took, I think, 40% or 50% pay cut. He gets a couple of millions a year. So he's trying hard to not have that sort of layoffs for the folks, the effects to come downstream rather than being absorbed upstream. So that sort of, I don't know what should we call it, culture, leadership, um, thought process is needed rather than like, oh, maximization of more, like 100 times more than that's already needed uh, to have a pretty awesome lifestyle. So, anyways, yeah, that's gets into the politics. But this notion earlier, I used to believe too, like, oh, automation is going to make everybody free and kumbaya, everybody dancing, and nobody's working, everybody has enough. But it should come with this also, right? I mean, if systems are taking care of the work we were trying to do now, that distribution of wealth has to, as you said, governments are there, they have to run, taxes are there, yeah. Anyways,
Yeah, I agree that there has to be a shift of, how you identify yourself. A lot of people, at least in the US, identify very much with their profession, and, that's kind of who they are, which I think will be easier in other countries where the happy moments of life are mostly free time and not your work. And you're very happy if you don't have work. So I think that will be like a psychological thing, but I don't believe, to be honest, like, look how governments in general are working. They kind of constantly try to extinguish fires. Not too much is really planned ahead well. So I think only a real shift will happen if shit hits the fan, basically. And then it will be a really not very sensitive, like, plan. Will be, okay, let's distribute more food stamps and, get taxes from those, then those leave, and then nothing is there anymore. And then, I don't know, I don't see it happening unless something really, like, what should happen is there should be discussions about this all the time, and then come up with a plan that makes sense. But will that work? Like, let's say you go ahead now, either as a Republican or Democrat or in any other country, and say, okay, this will happen, we will have to give out a lot of money, and just, we still afford schools, we still will pay for schools, but we won't really need educated people to get income tax. We just do it out of, because we are a democracy, we need educated people that can read and so on. So do you think people will vote? People will say, I'm not paying taxes, so everyone will get free money, and so it will only work once everyone that is important enough is out of jobs, and universities will crumble down because nobody is willing to pay tuition anymore. Only big lobby, when those are affected, like big lobbies, then something will happen, like lawyers, big universities, things like that. Because why Spotify started to exist and pay musicians? It was because musicians were under, most of them were under contract back then from big companies that had a lot of influence also on politics, so they had kind of that backup. Why artists don't have it right now and why nothing is happening is, you know, all these artists that put their images out there don't have a lobby behind them. It's just everyone fends for themselves, basically. And that's why it's going way slower than it was with Spotify and Napster and so on. I don't know. Does anyone have something else they want to share and add? If not, we'll close the room soon. I'll have to get around to get dinner. But well, thank you so much. This was a really great discussion, and I think this is really important work. And I'm glad that our guest speaker came, because I think that type of work will be really important to make these decisions and add real data, real facts to those discussions for the future. And yeah, thank you everyone for coming to to contribute and to make all these references. It was a really fun discussion. Thank you so much, everyone.
Yeah, thank you so much for organizing, Katarina.
Yeah, and yeah, if you like discussions like this, as you know, come back. Next week on Wednesday, we'll have Dr. Klein and how stem cells decide to die or regenerate. There's kind of a switch, and the scientists will, Dr. Klein will talk about that switch and how to influence that. So, yeah, thank you. Sorry for the background noise, and happy weekend, everyone. Thank you. Bye.